This video will cover the second page of notes for the topic of inverse functions. Let's try finding inverses. For example number 1, let's say we have points, and our job is to find the inverse of f and the inverse of g. So right here for part A, we have the function or the set of points of f. So we can see we have 1, 2, 3, 4, 5 points. So I just showed you how to use the horizontal line test to decide if it's one-to-one. Because the very first question we have to ask is f one-to-one? So one way we can do that is by plotting those points. So that's what you see over here. I'm plotting points. So I plug in -2, 1. That's this point. -1, 0. I plug in 0, 1. I plug in 1, 2. And I plug in 2, 2. And we can see here that if I did a horizontal line here, it would actually cross those 2 points. So f is not one-to-one, therefore we cannot find the inverse of it. Now let's go find the inverse of g. So that's going to be part B. We're going to do the same thing. We're going to graph these points to see if it passes the horizontal line test. So I'll go over here to 3, 1. I'll go to 0, 2. I'll go to 2, 3. And I'll go to 4, 0. So we can see that there is no horizontal line that's going to cross more than one of those points. So we do see that it's one-to-one. If it is one-to-one, then we can go find its inverse. So the inverse, believe it or not, is simple by just switching the x's and y's. So in other words, the point 3, 1 now becomes the point 1, 3. The point 0, 2 becomes the point 2, 0. 2, 3 becomes the point 3, 2. And finally, the point 4, 0 becomes the point 0, 4. So we have found our inverse of g to be these sets of points. For example number 2, what if they gave us equations and our job is to go find the inverse of f of x and the inverse of g of x? So we're going to do these separately. So here's f of x. We have f of x is equal to 2x plus 5. First question is it one-to-one? Because f of x is linear, we know the answer is yes, it is one-to-one. If it is one-to-one, we're going to go to step number 2, which is to switch the x's and y's, just like we did in example number 1. So in this case, we're literally going to change our f of x into a y, and then we're going to switch the x's and y's. We're going to switch their places. So instead of having y is equal to 2x plus 5, we're going to have x is equal to 2y plus 5. So the next thing we need to do is to solve for y. So just like we did in the review, so that's what this is, see the review and reflect video, and you will see that we're solving and we found that y is equal to x minus 5 all over 2. And we talked a little bit about how we can rewrite that as 1/2 x minus 5 over 2. Either way, we're going to change that y and change it into f inverse, and we have now found f inverse to be x minus 5 all over 2. Now let's go to part B. Our job is to look at g of x, and g of x is x squared plus 2. Well, we know that that is a quadratic equation. With the plus 2 means that it went up 2, and our quadratic equation would look like this, which is not one-to-one. But check this out. I said that there's a domain restriction, meaning that only the values where x is greater than or equal to 0 will count. So that means this part of my graph is gone, and I only have half a parabola. And now that we look at this half a parabola, we can see that yes, it is one-to-one. So if it's one-to-one, then we can go find its inverse. First, by switching the x's and y's. So instead of having y is equal to x squared plus 2, I'm going to have x is equal to y squared plus 2. Notice I also changed the x's and y's over here when we were looking at our domain restriction. In other words, instead of having x is greater than or equal to 0, I actually have y is greater than or equal to 0. So I'm going to keep on going. I'm going to solve for y. I just did the dub property first, so I got my y stuff on the left and my x on the right. I subtracted 2 to both sides. I took the square root. Don't forget the plus or minus square root. And then I have this as my inverse. But wait a minute. Remember, it says only if y is positive. So when we had our plus or minus, if I want y to be greater than or equal to 0, I'm only looking for the positive side. So you can see the F inverse here is good only because we're looking at the positive version of it. We don't really need to put this at all to show that this is our inverse. And that concludes this video.